All right, so once we get to this point, I would say we've got x and x. And 1,600 divides, you know the whole factoring thing that we learn here when we do the guess check factoring? We do x and x, and we look for the factors of 1,600, and you choose the ones that are closest together to start with. This even works here, okay? So the closest together factors of 1,600 are 40 and 40. 40 times 40 gives me 1,600. You'd have a calculator for this, and I know that's a little bit like guessing, but the square root of that gives me 40 and 40. And in fact, that does add up to negative 80 in the middle. It also makes it easy to not have to choose an answer because they're the same. So we must sell 40 units of this product, okay, in order to get that. Okay? Does that help on that one? All right, let's take a look at 7. Did we have a decent setup for 7? No? What did 7 look like? Okay. 7 looks like example 7. So kind of going back to that one, just to talk about, I'm not going to pull that one back up, but we had a little bit of a setup for ourselves here. That was, am I on the right one? Yes. Okay, total revenue or profit is equal to the rent per apartment times number of apartments rented. In this case, this would be units rented or office. Okay, so maybe I'll change that to unit for this one. All right, now, reading through this, first, how much do they want to make total? Okay, so that's going to be my total, $20,240. Now, they tell us we're starting with the rent at $400, but if you look back at example 7, remember we had like an expression for the rent and we had an expression for the number of units. We said we're kind of starting at a base of 400, but we're thinking about changing that rent, and we're thinking about making it $20 more, or 20 more than that. So we said we can increase this several times by $20. So we said 20x. So we're going to say rent is kind of plus or minus $400 going up 20 if we feel like it. What about the number of units rented? What is it starting at? 50. And every time we increase the rent by 20, what happens to the number of units rented? It goes down by 2. Because it's every time we increase by 20, we also have to say every time this decreases, it goes down 2x. Because we're not sure how many times we're going to increase the rent, which means we're not sure how many times we're going to lose apartments. Okay? From here, what would be a good way to solve? Okay, we could FOIL this out. This is bigger numbers, so you would definitely need a calculator for this. 400 times 50, I think, is 20,000. Minus 800x plus 1,000x minus 40x squared. Anytime I have a quadratic, I move everything to the left to factor. So I'm going to take that negative 40x squared and move it to the left by adding it. What is this going to give me? 200x. Okay, so we need 200x, but we're going to move it to the left, so it's going to be negative. And then I'm going to subtract this 20,000 from this 20,240 to get 240. Is that correct? I think so. In order to factor this, what must we do? Greatest common factor, which is what? 40. Which gives me x squared minus 5x plus 6. What factors of 6 add up to negative 5? It's a positive 6 at the end.
-6 and positive.
So we need 2 and 3. Yeah? So I have to do it as x minus 2 and x minus 3. Okay, why can I not use -6 and positive 1? Because I can't get the, I can get the 5 with that. -6 and positive 1. What I can't get is the last term. The last term needs to be a positive 6, and if I do it as a -6 and a positive 1, I get a -6. And that's not okay. So we've got to do the -2 and the -3. Okay? And then if you remember from our example in class, we finished up by asking the question, how much rent? So we went back to this expression for rent and plugged it in. Okay? That one then would tell you that you should charge either 400 plus 20 times 2. So that would be 440. Or 400 plus 20 times 3, which would be 460. Either one. Okay. Questions on that one? That's another one that I feel like having the formula for that may help. Not that it helps you with like the expression within that, but at least gives you a starting place. That would be a good one for that. Okay. Did we have anything good about 8? Anything? That one has the formula for you. They tell you R is equal to 800p minus 7p squared, where p is the price in dollars. At what price will the revenue be $10,000? If I just paused there and didn't have this, what would you do? Put 10,000 in for R and solve, right? Okay, good, because that's what you should do. We'll worry about the part I scratched out in a minute. Let's just say I put 10,000 in place of R. Do we know how to solve something like that? Move everything to one side and factor? Well, I don't think there is a GCF for this one. Okay, so let's talk about that. I'm going to move everything to the left. So this may not make sense when I say this the first time, but like if you noticed on the previous one that we factored, so like on 7, there was a nice big greatest common factor that took it down to like really nice numbers. It's either going to be that way or it's going to be like number 5 on the previous page where like 1600 was 40 and 40 and it was pretty basic factors. Like don't think you're going to have to do like 35 times something random to get 10,000. They're never like that. But the alternate, remember when we're factoring quadratics? These are quadratics that would be on the graph somewhere, right? What else is the answer for us? Does anyone remember what on the graph what the answers are? The intercepts, yeah? So like if you really got stuck on that kind of question, finding what factors of 10,000 add up to negative 800 and trying to do that, go graph it. Find an x-intercept. That's your answer. It's the same thing. So you could do both. You'd have a calculator. If I was to factor this, just because that's where we're at here, I would say 7p and 1p, because I don't have a choice. I want factors that when I put them in add up to 800. All right, so here's how I would start. I would find some easy factors of 10,000. Do we remember the factoring rule that we start with like the closest ones together for factoring? So I'm not going to do like 10,001 or 10,000 divided by 2. I might start by saying, what's 10,000 divided by like 50? So like 50 and 200 would be a decent option to try. 10,000 divided by 100 would be 100 and 100. Those would be the closest ones together, and that's what our factoring tells us to try first. So I would try 100 and 100. How do I know if those are the right answers? Okay, you do the outer terms and the inner terms. So what would be the 7 times 100 here? 700. And what would be 100 and P here? 100. Does that add up to the 800 in the middle? Yeah, so like the rule of thumb about the closest ones being the right ones, it should help us a lot when it's big numbers. Because notice this one was 100 and 100. The last one was 40 and 40. They're not going like crazy weird numbers on these, okay? So this tells me the price can equal 100, or the price can equal 100 divided by 7, which is 14.28. Now, I scribbled out that small section there. Let's erase that and come back to it. The price must be greater than what? 50. Which of those is my answer? 100. That's what that was telling us, not any more information for the problem. It was telling us which of our answers we should keep. Okay. Yes, ma'am?
Why did you divide by 7?
Why did I divide by 7?
Yeah.
If I was setting this equal to 0,
Okay.
I added 100 and divided by 7. Yes? Do we need 9?
Yes.
Okay. This one, I'm just going to show you what it means, and then you'll tell me it's the easiest problem on the homework. They tell me it's this many units for supply and this many units for demand. Now read this sentence carefully. At the value of P for which supply equals demand. What are they telling me to do? Set them equal to each other and solve. That is it. Okay?
10 and 11.
That we would like to enclose a rectangular area of 11,200 feet squared. Okay. Okay, that's the area. One side will be bounded by the building and the other 3 sides by fencing. So in other words, back here somewhere there is a building, but we're going to put fence around 3 sides of this. These 3 sides. If 300 feet of fencing will be used, what will be the dimensions of the rectangular area? This one to me had 2 different parts to it. The fencing goes around the outside. If you remember that from geometry, what do we call like the outside? Your perimeter. So I was thinking in my head there's a perimeter thing, but then what did they tell me about the whole thing? They told me what the area was, okay? So I'm not saying this is the only way to do it, but I almost thought about this like a system of equations, okay? Because that's just what came to my head. There's probably a different way. That's fine. I'm going to go ahead and call the sides X and the length of it Y. Are we okay with that? Okay, so what does perimeter mean we usually have to do? Add them up, right? There's like a 2L plus 3W formula, but am I really doing all 4 sides? No, I only care about 3. So I know that 2 sides of X plus 1 side of Y is going to add up to, what's the total fencing? 300. That's my perimeter formula. We good with that one? All right. And then I know one more thing. I know about the area, right? How do I find area of a rectangle? Length times width is equal to, in this case, what? 11,200. So I have 2 formulas here. Do we remember a way to solve a system of equations that could help us? What are our methods of solving systems? Elimination or? Substitution. Elimination works great when you have 2 like X plus Y equations. But that second one's kind of throwing me off here because it's a multiplication. So I might try to substitute here. Okay, so let's say, which of these is better to solve for?
Right.
Okay. Can I solve for this Y?
No. Yes.
Yeah. Okay, so let's solve for that y. What does substitution say that I can do then?
Now you put that in for the y on the right.
Put that in for the y on the right. So I take the x, I take out the y. In place of that y, I'm going to put negative 2x plus 300. Now everything is in terms of x, and I can solve. What should I do to solve? Distribute. I should distribute my x. That would give me negative 2x squared plus 300x is equal to 11,200. Yet another factoring question. I would move everything to the right. For the sake of my paper, I'm just going to go over here and start working, moving everything to the right. Again, big numbers for this. What do I have as a greatest common factor? 2. 11,200 would be, that divides in 5 times, with 1 left over, 5,600. Okay, now let's stick with the rule about factoring. Closest factors of 5,600. Let's see if it divides by like 40 or something like that. 5,600 divided by 40. Oh, 70 and 80. Those are close. Let's see if the closest ones together work. 70 and 80. Would those add up to negative 150? Actually, yes. So I would do x minus 70, x minus 80. Okay. Now, x represented what for this?
5.
That. Okay, so x could be 70 or x could be 80 in this case, which kind of leads you to 2 separate answers. If x is 70, then, well, we have to check if it would work. Yeah, both would work. You could have 2 sets on this one. So you could have 70 or 80 for the width, which would give you 2 different lengths if you plugged them back in here. Okay. All right. Questions? I know this is getting like a bit much, but that's kind of how it is. All right. Last question from the homework. 11. All right, so they've got a candy bar, chocolate candy bar that's got a 10 centimeter long, 5 centimeter wide, 2 centimeters thick. That is going to give me volume. Okay, does anyone remember how to find volume of a rectangular anything? Okay, so I'm going to start by saying volume equals length times width times height. My original volume is 10 times 10 or 100. All right, because of chocolate decreasing in price by 60%, the company's decided to reward its loyal customers with a 50% increase in the volume of the bar. So instead of being a 100 volume bar, what would be a 50% increase on that?
200.
Okay, so what is half of the original amount? 50. So half of the original amount is 50, therefore the new bar is now 150. Okay? The thickness will remain the same, but the length and width will be increased by equal amounts. Do we know what that equal amount is? No, this is going to be my x. So what they're trying to lead you to set up is this. Your new volume is 150. You are changing the length. It was 10, but we would like to increase it by some amount. We don't know what that is. So how do I show increase by some amount? Plus x. The width was 5. We would also like to increase that by the same amount. So plus x. The only one that's not changing is the width. or the thickness of that, so we're going to leave that at 2. And then I could solve. I feel like we've solved a lot of these, like FOIL out and factor. I would divide both sides by 2 here, FOIL it out, and factor from there. Okay? Are we okay thinking about the solving on that one? Okay? All right. Now, for 1.5, you're looking at this page of your notes. Okay? Because it's all on the calculator, I'm going to remove my notes from here and show you how to type it in your calculator. One at a time, because we all have different types. Okay? So let's start with the 84, because that one will load up first.
Yes.
And then I will show you the other one. Okay? Honestly, on the Inspire, you guys can probably figure out how to type it yourself if you go under the button next to the number 9, the little templates menu on the Inspire. There is the little, you see the little zigzag E thing on like the second line to the right side. You can type it in from there. Okay. I didn't get to 84 yet, so hang on. On the 84, let me pull up the calculator. Yours is under the math menu. Okay. If you scroll either all the way down.
Wait, my calculator.
Wait, assistance.
Matt, you can do this.
Okay.
My calculator is in Spanish.
I'm here.
Okay. I'll deal with that in a minute.
Dude, you're on the wrong calculator.
All right. This is the 84 calculator. If you're the Inspire, just hang on a minute. On the 84, this is on the math menu. You can either scroll all the way down or hit 0, and you get summation. Hit enter. You're literally going to fill in what you see on the paper. I would use X's rather than N's just to be consistent. So if it was me and I was looking at example 1, instead of N, I would type X equals. X is the button next to alpha. It says X, T, theta, N. I would type in X equals 3. At the top, use the arrow to do that. 7. Then I would type 5. Use this X button next to the alpha. X minus 2. Hit enter. That's your answer. Okay? That's the 84. Super difficult, right? Inspire.
Mine's broken.
Okay, I'll be there in a minute. Inspire, I'm going to pull yours up and show you that in a minute. Okay, 84 people. You have a job now. If you can type that in, try to type in B, as well as the 3 questions on the back. Just keep in mind you use X every time. It doesn't matter what variable they have, you use X. Inspire. Let me get this one in here and get it a little bit bigger. There's other places for the Inspire to find this, but I kind of find it easy to just go in the button next to the number 9 right here. This is your little menu. You can get a lot of things that you don't know how to find here. I would use this one right here that's highlighted in blue next to the matrices.
Wait, where'd you click?
The button next to the number 9.
Just the one next to the matrices.
The one directly next to the matrices over here that looks like that squiggle E. You guys can use whatever letters you would like to because you have like that keyboard at the bottom. I just stick with X because I feel like it's simple. Did you find it? Okay. So I would do, again, X equals 3. You use your arrow to get up to the top, do 7, and in the parentheses, type in 5x minus 2. As long as you use the same variable for everything, you will be okay. All right? I'm going to pause for a minute. What I'd like for all, if you type in B, you should get out 97. Accurate? Okay, on the back. A should have been 284. B is 25,580, I think, if I can read my own writing. And I'm not going to be able to pronounce this number correctly because I can't think about it. It's 241,80300. Yeah? Okay. 24 million? I didn't put my commas in, so I can't pronounce. All right. Let's look at the homework quick on this so I can tell you what you do and do not need to do. All right. I really feel like there's just not that much needed on practice. We're crossing out 7 through 12. Let's just do the odds besides that. Odds?
So 1 through 6 and then all the odds.
No, literally just the odds. Yep, just the odds. Okay? All right. There's a few that I just want you to be able to practice putting the parentheses in here at the end because how you type it in really matters. So that's why I did want to do just like 2 of those. Okay?
Is it just a matter of 2 variables?
Oh, wait, don't do 25.
15 has an N and a K.
So stop at 23. 15 has an N and a K.
N and a K.
That's a good question. I think that should just say N. Wait, no, don't do 15 either. Okay, cross out 15, cross out 25, do the rest of them odds. No 15, no 25, and do the odds besides that. Okay? Now, I have until 11:35. So when we look at example 1, we have a company that manufactures aquarium heaters. We have combined cost for labor and material is $21 per heater. Fixed costs are $70,000. If the selling price of the heater is $35, how many must be sold for the company to earn a profit? Okay? Just for clarification, when it says earn a profit, does it say how much? No. Okay? This is saying greater than $0. Anything greater than $0. What does this bring anything to mind that we've done? Anything. Inequalities. Anything that we did with word problems? Yes. Which one?
See profit.
Yeah, profit. We see profit. What else do we see? Yep. Fixed costs. What else do we see? I see selling price. Okay? All of these things put together are leading me to big old profit equation. Okay? So that one, if I was to copy it down again. Profit equals. Anyone know what that is? What comes? Or do you see it?
1.
We'll get there in a second. Hang on. I'm not filling it in yet. I'm just writing down the formula. Allie, which one were you saying? Okay. So we got total revenue minus total cost. And we get total revenue by saying selling price times number sold minus, in parentheses, variable cost plus fixed cost. Okay. So what do we have here? What's my fixed cost? 70,000. What else do we have? Selling price is what? 35. So I put that in for selling price. What usually goes next to that? X. Minus. What else do we have? We are finding the number sold. Do we know anything else? Okay, the variable cost is 21. It does not say the words variable cost, but it does say that in order to make these heaters, it costs $21. As soon as I see this per heater, While it does not say variable cost, that means for every single one, which means it's happening again and again and again. So I would like for this to be 21x in here for my variable cost. Now, what did we say? We want to make a profit that is what? Greater than 0. So I'm going to say that all of this, my profit, must be greater than 0. Now, does it matter if I actually equal it to 0? I could, right? And I could just word my answer such that we must sell more than this number. This number hits 0. We must sell more than this. And I could do that very, very easily. Okay? Do you need help solving? Solve that real quick. That they must sell at least or more than 5,000, right? 5,000, you'd break even. You need to sell more than 5,000 to earn a profit. Okay? If you want to use a greater than symbol to show that, you can do that. If you want to set it equal to 0 and then just tell me in words, they must sell more than 5,000, that's also fine. Either way. Okay? Again, that formula, what I'm hoping for is given the formula, you can get close to something. That's my goal. That's where we're at right now. Okay? We comfortable with that one as much as we can be? All right, let's take a look at 2. A builder must decide whether to rent or buy an excavating machine. If he were to rent the machine, the rental fee would be $3,000 per month, and the daily cost would be $180 for each day the machine is used. If he were to buy it, his fixed annual cost would be $20,000, and daily costs would be $230 for each day the machine is used. What's the least number of days each year the builder would have to use the machine to justify leasing it rather than buying it? Okay, this one has a lot of days, years, months, that kind of stuff. That can get confusing. Let's just settle this right now. Least number of days. That's your X. We would like to know number of days. Okay, let's take this one situation at a time. This is one of those where you have 2 situations that you're comparing, one on each side. So let's take a look at the first one. $3,000 per month. Let's just say each one of these for a year. So if it's $3,000 a month, how much is that a year? $36,000. All right. Plus 180 for each day. If each day is X, how do I show 180 per day? 180X. Let's consider the second situation. If he were to buy it instead of rent, what's his starting costs? $20,000. Plus, what are his daily costs? $230 per day. Okay, we would like to justify leasing it rather than buying it. Okay, in other words, we would like the cost of rental to be less than the cost of buying. Which way do I put my inequality sign? Which side do I want to be less? I want the left side to be less, so I want that to be that. Take a minute and solve. Okay, so given the word problems we've talked about, we cut down 1.3 to 1, 2, 4, and 5. Okay, we're not going to add anything back from the 1.1. We didn't do 12 and 13, and that's fine. 1.5, the summation stuff won't be on this quiz necessarily. So back to 1.2 and 1.4. That's your inequalities and absolute value. Okay, that's going to be the bulk. Okay. I'm going to aim for roughly 3 word problems. 3. I will give you a formula. Okay, so what I'm going to do is I'm going to break down the word problems. Okay? That's not a bad question, yeah, because let's see, what did I do? I don't know. Different pieces. I separated them into pieces so that you are answering different questions about them, not to make them harder, but to break them down into manageable chunks. So hopefully what it's going to do is you'll be able to answer something small about it, then maybe an equation, and then maybe solve the equation but split up the points so that it's not like all your eggs in one basket type thing. Okay? Now, think about the ones we've covered. Anything sticking out to you that are major questions that we've gone over a bunch of times? Or at least a few times. Types of questions that we feel like we have focused more on. Do you need me to tell you what we focus more on? The big old profit equation. Okay? Big old profit equation. Feel like there should be one like that. I feel like that would be a good one. We've done that several times, and I feel like that is something we may be reaching as a manageable level. The big old profit one. There are a couple that we've done with that, like expanding the area one with the rectangles. And then, I don't know, maybe something similar to the like 4 or 6 on the last homework, which is kind of like this example 2 as well, where you have like a fixed cost and a variable cost, but it's not the whole profit thing. Something similar to those kind of things would be where I'm aiming for, things we've done multiple times. If it is something totally random that we have not done many times, I will probably not put it in there because that doesn't seem fair to me. I'm going to go for setups that are similar to things that we've seen multiple times. Okay? That's my goal on that one. Okay? Questions about the quiz? You got about 10 minutes if you want to knock out some of those summation ones before you leave. I'm going to edit the homework so that it's reflected properly on my PCA, and we'll go from there.